Hi class. So this week we're covering chapter 11, sampling. So let's start off with defining some things. Sampling are strategies that are used to select a given number of individuals or things from a population. So basically you're taking a sample or you're taking a portion of a bigger group. Population is all the individuals or groups the researcher is interested in for the study. So you take the sample from the population. The accessible population is one which the researcher can potentially access either because the agency works with them or due to geographical proximity. So basically meaning that the researcher can access the population. Unit of analysis is what is being compared: individuals, families, communities, or nations. So what are you comparing? Okay, for example, individual students as the unit of analysis would be in a study that focuses on gathering data about individual students' experiences of being bullied. So here, the unit of analysis would be the students. If we focus on students' perceptions of the culture of their classrooms as it relates to bullying, then the unit of analysis would be the classroom. So the unit of analysis is what is being studied or what is being compared. The sampling frame is a list of all those in the accessible population, which is used to select individuals for the sample. For example, to collect data from the students about their experiences of being bullied, the sampling frame would be the students in the school. To collect data from the students about their perceptions about the culture of their classroom as it relates to bullying, the sample frame is the classrooms in the school. So there are two types of sampling strategies: probability sampling and non-probability sampling. So whenever you're writing your final project plan, whenever it asks to describe your sampling strategy or what sampling strategy was used, this is the chapter you would be referring to. This is what it's talking about. What strategy? Was it probability? Was it non-probability? And we're going to go deeper into what falls under probability sampling and what falls under non-probability sampling. So with probability sampling, we can determine the probability that any individual in the sampling frame can be selected. So, for example, the selection of individuals can be done to make sure that each person has an equal chance of being selected or an equal probability of being selected. So we use probability sampling to produce a representative sample. And a representative sample is one that closely matches the population from which it was drawn. So when a researcher says that they have a representative sample, they mean that the sample that they drew from that population closely matches what that population is. And this can only be done with probability sampling and random sampling, and we're going to talk about that here in a little bit. Non-probability sampling is when it is unknown what the chance was for that individual to be selected. So with probability, each person has an equal chance to be selected. With non-probability, we don't know what the chance was for that individual to get selected. Usually with non-probability sampling, this occurs whenever you select your sample based on convenience sampling, because you just select them because they're accessible or available. So random sampling, or also known as simple random sampling, we talked about how with random sampling, it basically means that equal probability of selection. And there are three selection methods: the lottery, random numbers table, and the software. So with the lottery, you assign a number to each person, writing the numbers on slips and then drawing the slips at random. With the random numbers table, a list numbering the individuals in random order is generated. Then numbers are chosen at random from a random numbers table. So individuals with corresponding numbers are then selected. So that's how you use the random numbers table. There's also softwares that you can use. There's programs like Microsoft Excel that can generate the random numbers used to select your individuals for the sample. There are also subtypes of this strategy. So you could have sampling with replacement, which involves putting a number of selected back into the original hat or the list so it can be selected again. So for example, if you have a hat with a list of individuals, once you record that number, you can choose to put that back in the hat, or you can do sampling without replacement, which means selecting the number and then not putting it back in the original list or in the hat. Random sampling seeks to reduce the selection bias, which can reduce the validity of inferences you want to draw from inferential statistical tests that you conduct to analyze your data. An assumption of inferential statistics is that the sample is obtained via random sampling. The disadvantages is that when some subgroups have a larger presence in the heterogeneous population, random sampling may not result in their representation in the sample. There may not be a list that contains everyone in the populations from which to draw the sample. So there are 5 steps to create a random sample. First, you want to define the target population, identify existing sample frames, or develop one. So find out what sampling frame you're going to use, or if you need to develop your own. You want to assign numbers to each unit of analysis. You want to determine your desired sample size. So it's important to know the sample size that you intend to use, and then randomly select participants either by using the lottery, the table, or a software. With systematic random sampling, the first person is selected based on a random starting point, and then the remainder is based on a fixed sampling interval. The sampling interval is calculated by dividing the entire population by the desired sample size. So suppose that a researcher wants a sample size of 100 and the entire population has 1,000 individuals. To calculate the sampling interval, the researcher would divide 1,000 by 100 and they would get 10. So therefore, the researcher would select every 10th individual from the random starting point. So advantage of using this strategy is that this sampling strategy is appropriate for use if the researcher has budget constraints. Then the disadvantage is that the strategy can produce a biased sample if the list of names were organized in some type of pattern. So for example, if we were to select 25 out of 200 participants from a list of names that was arranged in alphabetical order, those whose names start with letters early in the alphabet are more likely to be selected to participate in the study than those whose names start with letters later in the alphabet. There are 7 steps to create a systematic random sample. So if you wanted to use this systematic random sampling strategy, you first want to define your target population, determine the size of the sample, identify or develop your own sample frame. Here you have to assign numbers to the cases as well, and then you have to select your random starting point. Once you select your starting point, then you can calculate your sampling interval, and then you select whatever case until desired sample. So stratified random sampling is used to compare 2 or more subgroups, or we also call them strata, of the population. So there's also proportional stratified sampling and disproportional stratified sampling. So with proportional stratified sampling, this is used if the researcher wants the sample size of each subgroup to be proportional in its representation to the population. For example, to study the effects of stress, burnout, and social support on social workers' well-being, a social worker wants to stratify the sample by gender because based on looking at a membership list, it appears that women are more likely to be social workers than men. So a proportional stratified sampling will accurately represent the population of the membership of the Social Workers Association in the state the researcher resides. So that's a good example of when you would use the stratified or the proportional stratified sampling. An advantage of this is that it reduces the sampling error when the variance between the stratified groups is large. The disadvantage is that it needs complete data on the variable used to stratify the sample on everyone in the population. With disproportional stratified sampling, this is used if the researcher wants the sample size of each subgroup to be disproportional in its representation to the population. So, an example of this would be the example from the book where they demonstrated how a disproportional stratified sampling strategy can be used to collect data from sheltered, homeless, and low income housed women. The population consisted of facilities where homeless women and low income women reside. The sample was stratified by type of facility, so the shelters and the housing units. Next, a simple random sampling strategy was used to select the participants from the shelters and housing units, with higher numbers of women being selected from small shelters and low income housing sites than large shelters and low income housing sites. There are also 7 steps to create the stratified random sample, which is similar to the other strategies. First, you define your target population, decide on the variable to stratify your sample and the number of strata that you plan on using, identify your sample frame or develop one, divide your sampling frame into stratas so that each stratum has a frame, assign a number to each unit of analysis, determine the desired sample size for each stratum so you can decide how many individuals, how many people you want in each stratum, and then select the target number of units from each stratum by simple or systematic random sampling. Cluster sampling is also known as area sampling. So here you have a cluster of participants. It involves selecting a cluster of participants from the actual population. There are 3 classifications of your sampling clusters. The first one is space-based. This can be states, countries, census tracts. There's also organizational based, so it can be a school district, grade levels, classes. And there's telephone based, which is your area codes. So let's talk about an example for cluster sampling. Let's say that a researcher is interested in the effects of campaign to reduce opioid use in persons who live in low-income neighborhoods. The researcher uses the US Census data to identify low-income neighborhoods in the country where she resides. She assigns each neighborhood a number. Suppose there are 32 neighborhoods and her desired sample size is 12. She would then randomly select 12 of the 32 neighborhoods. Members of households in these 12 neighborhoods would be included in her sample. There are 2 subtypes of the cluster sampling. One stage cluster is when the sample is obtained by selecting the cluster. 2-stage cluster is when you select the cluster, which is the first stage, and then you select individuals from each selected cluster, which is a second stage, via random sampling. So the advantage of cluster sampling is that it's appropriate to use when the target population is widely dispersed geographically. So if you are doing research on a large geographical area, if your population is just dispersed all over the place, cluster sampling is great because then you can just select individuals from a specific cluster. The disadvantage is that clusters may not produce a sample as representative as obtained by using a random sample given the same sample size. There are 5 steps here on how to create your cluster sample. Again, we define our target population, we determine our sample size, we identify our sample frame, we determine the number of clusters that we want to select, and then we randomly select target number of clusters. All right, so now let's talk about the non-probability sampling. Convenient sampling. Basically, with convenient sampling, it is based on accessibility. So it involves selecting persons from the target population because they're easily accessible to the researcher. So for example, if I'm doing a research study and I decided that I'm going to use my research class as my sample, that would be convenient sampling because you guys are easily accessible to me. You're taking my class, so I have class with you guys. I see you every other week. I have access to your email address that I can just email my survey. It's convenient, right? You're really easily accessible to me. So the advantage of convenient sampling is that it's less time consuming than random sampling, right? Basically, you know who your sample is, they're convenient. You can access them really easily. So basically, you just send the survey to them. You don't have to do any other steps. The disadvantage of convenient sampling is that persons from hard to reach populations may not be included in the sample. Basically, with the convenient sampling, the whole purpose is that you can easily access these people. So the disadvantage is that there may be other people that should be included in this research study that you're doing, but because they're not easily accessible, they are not going to be a part of the sample. 4 steps to create your convenient sample is to define your target population, identify ways to use to recruit these individuals. How are you going to get your sample? Determine your sample size, and then select the target number of individuals. Purposive sampling is also another form of non-probability sampling. So, purposive sampling involves selecting persons from the target population because of their fit with the purpose of the study and inclusion criteria. So, there's a purpose. You are intentionally selecting these people to be a part of your sample. Criterion sampling involves selecting participants based on the criterion established by the researcher. So the advantage of using purposive sampling is that you can use that in both qualitative and quantitative research. The disadvantage is that it's time consuming. Here are the steps to create your purposive sample. Define your target population, identify inclusion and exclusion criteria. So basically determine who should be included and who should be excluded. Identify ways to recruit individuals who meet your criteria. Determine your sample size, and then select your target number of participants. Snowball sampling involves selecting participants from the target population because of their fit with the purpose of the study and inclusion criteria. Once the researcher finishes surveying or interviewing the participant, the researcher will ask the participant to tell others about the study. So if someone the participant spoke with is interested in participating in a study, they would be instructed to call the researcher. The advantage of the snowball sampling is also that you can use it in both qualitative and quantitative research. The disadvantage here is also that it's very time consuming. So the steps to create a snowball sample is the first 4 is the same as a purposive sample, right? Where you basically define your population, you identify the inclusion and exclusion criteria, you identify ways to recruit those people who meet the criteria, and you determine your sample size. Once you do that, then you also want to recruit individuals and survey them. You want to ask them to refer others to the study. Then you also want to contact those potential participants and determine if they're eligible or not. And you want to continue doing this until you reach your desired sample size. Quota sampling involves obtaining a sample that is as representative as possible in relation to potentially confounding variables and of a specific size or quota. So those confounding variables are basically variables that relates to both your independent and dependent variables that may also be causing that relationship or that association between those variables. So the spurious association is one where the researcher thought that there was a relationship between the independent and dependent variables. However, it's usually that another variable explains away this relationship. So the subtypes of quota sampling is proportional quota sampling and non-proportional quota sampling. With proportional quota sampling, the researchers want the sample size of each subgroup of the confounding variable to be proportional in its representation to the population. With the non-proportional quota sampling, the researcher wants a sample size of each subgroup to be disproportional in its representation. The advantage of quota sampling is that it includes subpopulations in the sample. The disadvantage is that it is time consuming to create the sample. There's also non-interlocking quota and interlocking quota. With the non-interlocking quota, each quota is considered separately, and with the interlocking quota, the quotas are considered jointly. So the steps to create a quota sampling, the first two steps are the same as the purpose of sampling. You also want to determine the quota central or confounding variable, determine your sample size, determine the number of individuals you want for each quota, then select your target number of individuals. So there are reasons why your samples may differ from the population. And these may be because of sampling errors, or non-sampling errors, or sampling bias. So sampling errors are produced by using strategies that overrepresent a portion of the population. Errors generally decreases as sampling size increases, and the random sampling can also help reduce error. One way to fix this error is to increase your sample size. So the larger your sample size, the lower your sampling error. Random sampling also reduces this error because if you're randomly selecting your participants, they all have equal chances of participating in the study. Therefore, it's more likely that they'll be closer representative to the population. Non-sampling error is due to differences between those who responded to the survey and those who did not, and how the survey was administered. So sampling bias is when your selection method resulted in a sample that is not representative of the population. So when you're evaluating the quality of a sample, you want to look at the representativeness. So with the representativeness of a sample is a measure of its quality. Generalizability means that a sample should allow the study results to be generalized to the population. Sample size should be adequate to produce valid results. This is important for social workers to inform practice, inform policy, evaluate the effectiveness of interventions. Your sample size also impacts the representativeness of your population. So larger samples and or more complex strategies may be needed so that you can capture the heterogeneity of the population. A power analysis helps determine your sample size required to produce a given effect size. So your effect size is a way of quantifying the size of difference between the two groups. So when you do statistics, you find that there is a difference, but the effect size tells you how much of a difference there really is. So all the power analysis does is that it helps you determine what sample size you need so that you can get a specific effect size. You can also determine your sample size by using power analysis software. And there are several factors that will be needed for that. So you need to know what your study design is, whether it's going to be experimental, non-experimental, observational. You want to know what your research question is, how many independent variables you're having, what are the levels of measurement for the variables, is the dependent variable normally distributed, what is the statistical analysis that you plan to use, what is the p-value you plan to use to test your hypothesis. Normally we use a 0.05 or higher. You also need to know what power level you plan to use. Normally we also use a 0.80 or higher. And you also want to know what effect size you plan to use. Normally, we use Cohen's d, and small is a 0.20, medium is a 0.50, and then a large is a 0.80. Social workers should consider how sampling strategies might present ethical dilemmas. Participants may receive remuneration for referring others. This may lead recruiters to pressure individuals to participate. Quota limits may be set so that each participant can recommend up to a certain number of potential participants. Remuneration amount should be acceptable to recruiters. They should be large enough to sustain interest and small enough to represent remuneration for recruiter time and effort so that it is not perceived as a source of income. So the purpose, the benefits, and the potential risk of The study must truthfully be explained to participants. It's always important that you explain to participants the purpose of the study, tell them what the benefits are, and also explain what the risks are. So it's important that researchers read studies from diverse participants so that they can learn about effective strategies that can be used to recruit people from diverse groups. So strategies to diversify your sample. You may want to interview participants in their home, maybe use bilingual interviewers and interviewers who come from the same racial ethnic background, maybe use formal ways to address the participants, ensure that the study has benefits for those participants in that community, and also placing flyers in places frequented by those potential participants. All right, this brings us to the end of chapter 11.